This is the lesson on similar polygons and similar shapes, what it means to be similar and how we can use similar shapes to solve for some missing dimensions. What it means, shapes to be similar, is that two shapes with all corresponding sides having the same scale factor and all corresponding angles to be equal. Okay, what that means is if we wanted to prove that these parallelograms are similar, first we would match up the corresponding parts. So M is corresponding with E, N would be corresponding with F, and so far around. If we look at the corresponding shapes, angle M and angle E have the same measure, N and F have the same measure. So if we go around, we already can see that all of the angles of these two shapes are similar. So the first part is done. So similar. Good. So all the angles are similar. The next part, we need to check to see if the scale factor for all of the dimensions is the same. So we want to find the scale factor of corresponding dimensions. We use scale factor equals model over original. We aren't sure if this is a reduction or an enlargement. We're not sure which is the model, but because we're just comparing the scale factors, we can actually choose. I'm going to set this one to be my model and this one to be my original. We're not concerned with what the scale factor is, we're just concerned with if it's the same. So if you did it the other way, you'll still should get the same result. I'm going to start by looking at the top and comparing the top here. So the scale factor is 3 divided by 2.25. And if we get our calculator, 3 divided by 2.25 is 1.33333. Or, so this is 1.33. Now let's do it properly. Or 4/3. Good. If we wanted to do the side, our scale factor is again going to be model over original. So the model is 2 divided by 1.5. And our calculator, 2 divided by 1.5, 1.3 repeating again. So 1.3. Here we can see that the scale factor, now let's get a different color, our scale factor for the top and our scale factor for the side are equal. So these are similar shapes. Okay, the other thing that we can do with these is if they are similar, that means that we can then use that information of shared scale factor to find more information. Looking at these shapes, given the quadrilaterals, find the length of JM. So JM is this length here. Find this length. To find it, we're going to make a comparison to this side using our scale factor, but we don't know the scale factor yet. Because the shapes are similar, we can find the scale factor for this pair of corresponding shapes, corresponding sides, and then use that scale factor to find that missing side. So we'll first find our scale factor, which is, we'll call this our original and this our model. It's useful to set your model as the one that you need more information about. If you do it the other way, that's going to be okay because we're looking for a length, not the scale factor. So the scale factor is model over original, 8 over 20. Right? 8 is the length of our model, 20 is the length of our original for corresponding sides. 8 divided by 20, get our calculator, we have 0.4. Okay, so we'll keep this, and we'll now use it to solve for JM, because we'll have our scale factor as model over original, so we have 0.4 equals, our model is JM, and our original is 16. So solving this equation for JM, multiply both sides by 16. Running out of space there, there's a white bar. 0.4 times 16 is 6.4. So 6.4 equals JM. There we go. So that is how we solve this.